Welcome to online classes. Today we will discuss exercise 4B, work out some problems from exercise 4B from the chapter Trigonometric Functions, and it's from Elements of Mathematics Volume 1. So let's start exercise 4B. In previous session we discussed exercise 4A, evaluated all problems of exercise 4A, but we discussed now exercise 4B for trigonometry. Okay, so let's start. We started from the question number 3, and the question number 3 is prove that sin A into sin B minus C plus sin B into sin C minus A plus sin C into sin A minus B equal to 0. So we have to prove it. So we take first LHS, and the LHS part is sin A into sin B minus C plus sin B into sin C minus A plus sin C into sin A minus B. Okay, so this is the LHS of the question number 3, where first bit, and we have to prove that this expression will be 0. So first we have to evaluate it. So here you can see you use the formula. Here you can see sin B minus C. So we can apply this formula sin A minus B. So here we can write sin A into the formula of sin B minus C, that is sin B into cos C minus cos B into sin C. Similarly, you can express the second term as well as first. So you can write here sin B into sin, you using the formula sin C minus A according to the formula sin A minus B. So here you can write sin C into cos A minus cos C into sin A, or you can write sin A into cos A. Okay, plus sin C into, similarly you can express the third term, that is sin C into sin A minus B. The formula of sin A minus B is equal to sin A into cos B minus cos A into sin A. So first we have used the formula of the expression. Now we can multiply, or we can simplify the expression, that here you can see multiply sin A of the first term, that means sin A into sin B into cos C minus sin A into cos B into sin C plus the next one, that is sin B into sin C into cos A minus sin B into cos C into sin A plus the third one, that is sin C into sin A into cos B minus sin C into cos A into sin A. Okay, so now we cancel the same term. Sin A into sin B into cos C is similar to the opposite sign of, you can see here the fifth term, that is sin B cos C and sin A. So we cancel first and fourth term. Okay, and the second part, second expression can cancel to sin A, sin C and cos B, that is the second and fifth, and the rest third and sixth. So if we cancel all these expressions, so we get 0, and 0 is the right hand side. So here we can prove that this expression is equal to 0. Okay. Next proceed to the question number 2, and 2 is similar to I. So we can solve the second bit for yourself. Now proceed to question number 3, because 1 and 2 are similar, so you can solve this. So next we discuss the question number 3 of third bit, and that is sine. We have to prove the LHS sine b minus c into sine b minus c by sine b into sine c plus sine c minus a by sine c into sine a plus sine a minus b by sine a into sine b. That is equal to, now we can apply this formula as you see in the numerator, that is sine b minus c. So we can apply the formula sine a minus b. So using this formula, that is sine b into cos c, and you know sine a minus b is sine a into cos b minus cos a into sine b. So here we can write sine b minus c, that equal to sine b into cos c minus cos b into sine c by sine b into sine c plus the next expression, that is sine c minus a. You can use this formula, that is sine c into cos a minus cos c into sine a by sine c into sine a. And the third one, or third term, that is sine a minus b. So here you can use the formula sine a into cos b minus cos a into sine b by sine a into sine b. That is equal to, now we separate the whole expression. That means you can write here sine b into cos c by sine b into sine c minus cos b into sine c by sine b into sine c plus the next expression is similar to the first. So similarly, you can make separated sine c into cos a by sine c into sine a minus cos c into sine a by sine c into sine a plus the third term, that is sine a into cos b by sine a into sine b minus cos a into sine b by sine a into sine b. Okay. Now cancel this same expression in both numerator and denominator. So here we cancel, that is sine b by sine b. So and here sine c, here so here the expression sine c to sine a. So here cancel sine c, and the next sine a, and the last one is sine b. Okay. So here you can write here sine cos c by sine c, that is cos c, you can write cot c minus, you can write here cot b plus cot a minus cot c plus cot b minus cot a. So here you can cancel this expression opposite sign, cot c minus cot c minus cot b plus cot b plus cot a minus cot a. So here the expression is 0. So this is the RHS part of this given expression. So here we can prove here this expression is equal to 0. Okay. Proceed to next question number 4. That is so here all these question number 3 we apply the formula addition and subtraction. So question number 4, that is tan square a minus tan square b is equal to sin a plus b into sin a minus b by cos square a into cos square b. So here we can take in right hand side, because right hand side is the complex related to the left hand side. So here we can write RHS is sin a plus b into sin a minus b by cos square a into cos square b. Cos square a into cos square b. So here you can use this formula sin a plus b into sin a minus b, and then we can multiply. But we have a formula is direct, that is sin a plus b into sin a minus b, that is equal to sin square a minus sin square b. Okay, so we can apply this formula, that is sin a plus b into sin a minus b, can express sin square a minus sin square b. Or you can write formula of sin a plus b and sin a minus b, then you multiply, then you get the result. This also, okay. By, or you can write here directly formula. If you have not this formula, then you can write the direct formula, that is sin plus b, that is sin a into cos b, okay, plus cos a into sin b. If you have not this formula, then you can use this direct formula, that is sin a into cos b plus cos a into sin b into sin a into cos b minus cos a into sin b, whole divided by cos square a into cos square b. That is equal to. Now you can apply this formula, or you can apply this formula, that is a plus b into a minus b form. So you can use this formula a square minus b square. So here you can see a plus b, and this is a minus b. So if you multiply, so you get a square minus b square. As you know, a plus b into a minus b is equal to a square minus b square. So we apply this formula, so we get sin square a into cos square b, because it's in a square form, minus b square means cos square a into sin square b by cos square a into cos square b. Okay, now we can separate both expressions. Then you can write here sin square a into cos square b by cos square a into cos square b minus cos square a into sin square b by cos square a into cos square b. Okay. So you can cancel the both denominator. Sine term of cos square b, and here cos square a cos square. So we get tan square a minus tan square. And this is the LHS part of this given expression. So here we can prove that sin a plus b into sin a minus b by cos square a into cos square b is equal to tan square a minus tan square b. So we can solve this all the problem in question number 3. Next we have to proceed question number 4. And question number 4 is question number 4, that is we have to prove that tan 75 degree plus cos 75 degree is equal to 4. So here we take LHS, that is tan 75 degree plus cos 75 degree. and that is equal to 4. So we have to prove that tan 75 plus cos 75 is equal to 4. So first we have to take LHS here. Now we can apply the formula, we can break this formula. Tan 75 we can write here in terms of sine and cos. So you can write tan 75 in terms of sine 75 degree by cos 75 degree plus, and you can take this formula cos 75, you can express cos 75 degree by sine 75 degree. Okay. Now we can take LCM, and the LCM is cos 75 degree into sine 75 degree, and in the numerators we use sine square 75 degree plus cos square 75 degree. Okay. As you know, in the class 10, sine square theta plus cos square theta is equal to 1. So here we can write 1 by sine 75 degree into cos 75 degree. So, but we have to prove that this expression is 4. So here we can write 1 by sine 75 into cos 75. So as you know, 2 sine A into cos A is equal to sine 2A. But here you can see 2 sine A into cos A, but here the missing is 2. So we multiply 2 in numerator and 2 in denominator. Okay, so the result will be 2 by 2 sine 75 into cos 75. That means we can apply this formula in terms of sine only. So here you can write sine 2 into 75 degree, and that equal to 2 by sine 2 into 75 degree, that is sine 150 degree. That is equal to 2 by 1 by 2, and that is equal to 4. And 4 is the RHS part of the given expression, and this is the formula that you can use. Okay. Next, proceed to question number 2 of the second bit is sine square 18 degree plus, this is the LHS, sine square 18 degree plus cos square 36 degree is equal to 3 by 4. That means we have to prove sine square 18 degree plus cos square 36 degree, that is equal to 3 by 4. As you know, the value of sine 80 degree root 5 minus 1 by 4, and cos 36 degree is equal to root 5 plus 1 by 4. So you use these values of the given expression. So you can write here sine square 80 degree. So the value of sine 80 degree is root 5 minus 1 by 4. So we can write root 5 minus 1 by 4 all square. And the value of cos square 36, that is root 5 plus 1. So root 5 plus 1 by 4 square of root 5 plus 1 by 4. So here you can simplify root 5 minus 1 whole square by 16. Similarly, the second part, root 5 plus 1 by whole square by 16. So now we can take LCM here, and the LCM will be 16. So here we can write root 5 minus 1 whole square plus root 5 plus 1 whole square. Now you can use this formula directly as a plus m minus b whole square plus a plus b whole square, or you can write directly the formula, that is a minus b whole square, that is a square, that is a 5 plus b square, that is 1 minus 2ab, that is 2 root 5. Okay. And the next, a plus b whole square, that is a square, that is 5 plus b square, that is 1 plus 2ab. That is 2, okay, by 16. Now cancel minus 2 root 5 plus 4 root 8. That is equal to 6 plus 6, that is 12 by 16. Now cancel 4. We can divide 4 both numerator and denominator, then we get 3 by 4. And that is the result of the given expression. So I can solve this problem second bit. That is sin square 80 degree plus cos square 36 degree is equal to 3 by 4. Next, the third one, question number and question number third bit is sin square 18 degree into cos 36. So we take first L is sin 18 degree into cos 36 degree. Sin 18 degree into cos 36 degree. As you know, the value of sin 18 degree is root 5 minus 1 by 4 into cos 36 degree is root 5 plus 1 by 4. So here you can see, you can use the formula, that is a minus b into a plus b, that is a square minus b square. So you can write here 5 minus 1, because a square means root 5 square of root 5. That means 5 minus b square, square of 1, that is 1. So 5 minus 1 by 16. So 4 by 16, that is 1 by 4. And this is the RHS of experiences. So this is a very simple problem that, as you know, the value of sin 18 degree and cos 36 degree. Next, proceed to question number 4, that is sin 15 degree. Sin 15 degree. So how to find the value of 15 degree? As you know, in our standard angle tables, 0 degree, 30 degree, 45 degree, 60 degree, okay? But we have not the value of 15 degree. So how to evaluate the value of 15 degree? Now you can express 15 degree as 45 degree minus 30 degree. That means you can write 15 degree in terms of 45 degree minus 30 degree, or you can express 60 degree minus 45 degree. 15 degree in terms of 60 degree minus 45 degree, because both the value are in our standard angles, 1530 or 6040. Okay, so you can express 15 degree in terms of 45 degree minus 30, or you can express 60 degree minus 45. So here we can take sin 45 degree minus 30 degree. Okay, so you can use this formula sin A minus B, and the formula of sin A minus B is equal to sin A into cos B. That means we can write sin 45 into cos 30 minus cos 45 degree into sin. Okay, so here we use this formula sin A minus B. So formula is sin 45 into cos 30 minus cos 45 into sin 30. So we can put the values or numerical values of this P ratio. As you know, the value of sin 45 degree is called 1 by root 2 in standard angle tables, into cos 30 is root 3 by 2, and minus cos 45 is 1 by root 2, into the value of sin 30 is 1 by 2. So if we multiply, then we have root 3 by 2 root 2 minus 1 by 2 root 2, and the LCM will be 3 root 2, that is root 3 minus 1. And that is the result of this given expression. This is the RHS of this given expression. Next, proceed to question number 5. That is cot pi by 8, that is the fifth bit of the question number 4, and that is cot pi by 8, cot pi by 8 minus tan pi by 8. Okay. Now you can express this expression cot into sin cos. That means we can express cot theta is equal to cos theta by sin theta. So we can write here cos pi by 8 by sin pi by 8 minus, you can use this tan into a sin and cos, that is sin pi by 8 by cos pi by 8. That is equal to, now we can take LCM, that is sin pi by 8 into cos pi by 8, and the numerator will be cos square pi by 8 minus sin square pi by 8. As you know, the value of cos square theta minus sin square theta is equal to cos 2 theta, because cos 2 theta has 4 formula. First is in terms of cosine, and second is in terms of sine, that is cos, and the last one is in terms of tan. So cos 2a or cos 2 theta have 4 formula, and the first formula is cos square theta minus sin square theta. And the denominator will be in the form, we can use the formula 2 sin theta into cos theta, and that is sin 2 theta. Okay. So what 2 is missing in this denominator. So first we can use this formula cos square theta minus sin square theta, that is cos 2 theta. So we can write cos 2 theta. So theta means here you can see theta is pi by 8. So you can write cos 2 into pi by 8 by sin pi by 8 into cos pi by 8. If we cancel this value, that is cos pi by 4. So here cos pi by 4 by sin pi by 8 into cos pi by 8. Now there is a missing in denominator, that is 2. So we multiply both numerator and denominator to get the formula. So here both numerator and denominator we multiply 2. So we get 2 into the value of cos pi by 4. Pi by 4 means it is a radian form. If we convert it to degree, that is 45 degree. So cos pi by 4 means cos 45 degree, and the value of cos 45 degree is 1 by root 2. So we can write here 1 by root 2 by, you can use this formula 2 sin into cos a, that is sin 2a, and you can write here sin 2 into pi by 8. So we can cancel the value, that we get sin pi by 4. So 2 1 by root 2 by, and the value of sin pi by 4 is also 1 by root 2. So we cancel this value 1 by root 2, 1 by root 2, then we get. So we can get the result, that is RHS. So this is the solution of this given expression. Okay. Similarly, you can solve this value, question number 4, that is, question number VI from the question number 4, that is cos 9 degree plus sin 9 degree. That is 6. Question number 6. That is, we can take here LHS or RHS. So, but in the GPSs, you can take RHS. So, the RHS is 1054. Have you known the value of 54 in standard angles? No, because we have not the value of 54, but we can express 54 as tan 45 degree plus 9 degree, because the LHS part in terms of 9. So we can express 54 is equal to 45 plus 9. But here 45 is in the our standard angle tables and 9 in the LHS part. So we can express 54 degree is equal to 45 degree plus 9 degree. Now we can use this formula, that is tan A plus B. And the formula of tan A plus B is what? That is tan A plus tan B by 1 minus tan A into tan B. So you can use this formula, that is tan A plus B, and the formula tan A plus B, that is tan 45 degree plus tan 9 degree by 1 minus tan 45 degree into tan 9 degree. That is equal. As you know, the value of tan 45 degree is 1. So you can write here 1 plus tan 9. Okay. By 1 minus, and the value of tan 45 is 1 into tan 9. That is tan 9. Okay. But the LHS part is in terms of sine and cos. So here I can break or you can express tan into sine and cos. So here you can write 1 plus tan 9 is equal to sine by cos. There is sine 9 degree by cos 9 degree by 1 minus sine 9 degree by cos 9 degree. Now you can take LCM both numerator and denominator. So here in numerator the LCM is cos 9 degree, and that is cos 9 degree plus sine 9 degree. And the denominator, the LCM of the denominator, that is cos 9, and the numerator will be cos 9 degree minus sine 9 degree. So now cancel the both denominator. So cos 9 and cos 9, and the result will be cos 9 degree plus sine 9 degree by cos 9 degree minus sine degree. And this is the latest part of the given expression. Okay. Similarly, you can prove VII 7 bit, that is tan 10 degree plus tan 35 degree plus tan 10 degree into tan 35 degree is equal to 1. So this is the last question of the question number 4. And that is, we have to prove in terms of the theta is 10 and 35. So we can write as we have 10 degree plus 35 degree is equal to 45 degree, because 10 degree and 35 degree are involved in this given questions. So we can a relation, that is 10 and 35, if we add them, then we get 45, and the value of 45 degree is our standard angle tables. Okay, so we can express the values, that is 10 degree plus 35 degree is equal to 45 degree. So the given expression in terms of T ratio 10, so we can 10 in both sides, that means 10 of 10 degree plus 35 degree is equal to 10 of 45 degree. Okay. Now we can use this formula, that is tan A plus B. So the formula of tan A plus B, that is tan 10 degree plus tan 35 degree by 1 minus tan 10 degree in tan 35 degree is equal to 1. So this is the formula, that tan A plus B. So we can apply this formula, and if we take denominator into right side, then we get tan degree plus tan 35 degree is equal to, the denominator will be multiplied to 1, and that is 1 minus tan degree into tan 35 degree. So here we can take the negative side of the RHS into a left hand side, then we get tan of 10 degree plus tan 35 degree plus tan of 10 degree into tan 35 degree is equal to 1. And this is the expression we have to prove it. So all our questions we have solved. Question number 4. So in this lesson we have discussed question number 3 and 4 in your exercise 4B from the books Elements of Mathematics Volume 1, and the chapter is Trigonometry. Okay, in the next session we will discuss question number 5, 6 and then proceed. Okay, so this is the, in this session we will discuss question number 3 and 4. Thank you.